And so what I'm going to do here, I'm going to start out with the PowerPoint slides here that you can see on the screen, and then we'll jump into our live presentation. So you should be seeing different windows on your screen right now, and what you can do is you can actually adjust those. You can adjust those windows into different sizes. So here on the bottom of your screen, you should see this bar here, and that bar should allow you to view the different resources throughout this presentation. And as I mentioned, they're resizable, they're movable, and you can access the resource list and also the Q&A. So we are going to have a Q&A session at the end of this presentation. And so if you have questions along the way, feel free to type those questions into the chat window. So this is a new interface. If you haven't seen this before, this is what we're going to be using going forward for all of our special interest groups. And we hope that you can take advantage of this and utilize some of the great features of this. So let's jump in here. And for our today's topic, we are going to be discussing optimizing foundation designs for construction costs and time savings with a safe approach and safe and practical approach in STAAD Foundation Advance. So before we discuss that topic, let's talk a little bit about the special interest groups, and then we'll jump into the specifics of what we want to talk about today. So for the special interest groups for STAAD, they're offered on the third Thursday of the month, and they start at 1 p.m. Eastern time. That's the same as New York time. And we do get credit for your attendance here. So if you're attending this presentation, you will get 1 professional development hour credit, and we have those transcripts available on the Bentley Learn server. Also, there's no cost for your attendance here, so you can just register for this online and attend at no cost. Okay. Now, let's talk about what we want to discuss today. We have 3 main topics that we're going to cover here, and they're all related to optimizing foundation design for construction costs and time savings, making sure that we take into account safety and we have a practical approach. So the first topic we're going to cover is utilizing the new efficient optimization algorithms for cost-effective foundation design. So what does that mean? Essentially, what that means is we've updated the software in STAAD Foundation Advance, and we've added an algorithm which helps to more efficiently optimize your foundation design. So we'll discuss exactly what that is and how that works. Also, the second topic we're going to cover is comparing your foundation design scenarios using automated material takeoff data to achieve optimal project foundation solutions. So that sounds a little complex, but what you'll see is it's not that complex. It's very simple. And what we've done is we've added in new material takeoff information into your foundation design report. And so now we can use that data to come up with the best scenario for our foundation on a particular project. And then the third topic we're going to cover is how do we take advantage of the enhanced foundation design calculations to maximize foundation design safety and efficiency. So we want to discuss what new enhancements we have to the program, and then how do we best use those enhancements to come up with the best design. So those are going to be our 3 topics that we're going to cover today. All right. Now, what are some of the benefits of talking about these topics? Well, obviously, new foundation design algorithms are going to improve the cost effectiveness for foundations in STAAD Foundation Advance. That's a huge benefit. Also, with the new material takeoff reports, it gives the structural engineers the data to calculate optimal foundation designs from a variety of scenarios. And then lastly, we can achieve an efficient and safe foundation design faster using STAAD Foundation Advanced to incorporate soil passive pressure calculations. So this is one of the new enhancements that we've added in, is being able to use the passive pressure calculation to get a more efficient foundation design. Okay, so let's now, we're going to switch over and jump into our live presentation. Now I'm going to stick with this PowerPoint for just a minute here because we want to discuss the workflow, the overall workflow for STAAD Pro and STAAD Foundation Advanced. Now this is a topic that we've covered previously, so I just want to take a few minutes to explain the workflow here. So as you can see, starting in STAAD Pro, you're going to first run your analysis and design for your above ground structure. And once you design and analyze your above ground structure, then you can take all that data, all that information into the foundation program to design your foundation. So we've seen this before. And so for this particular structure, we actually have an electrical substation structure here that is going to be the above ground structure that we're designing. And then we want to design our foundations from that. So right from our STAAD Pro Connect Edition, we'll be able to access our foundation design. Now, when you choose the foundation design, you can choose what loading you're going to bring over into the foundation program and what support locations that you're going to bring over. So in this case, we have 2 support locations that we're going to bring and design foundations for, and we have a number of load cases that we're going to bring in. Okay, and then from that, all that data is going to transfer into our foundation program. Now, the great news about all the topics we're going to cover today is that if you have just a license for STAAD Pro and you don't have a license for STAAD Foundation Advanced, you can still use the features that we're going to cover today. So that means that you can install STAAD Foundation Advanced and you can use your STAAD Pro license to do these types of foundation designs. So everything we're going to cover today will be included with your STAAD Pro license, even if you don't own a license for STAAD Foundation Advanced. So it gives you the ability to design these foundations and optimize them in an efficient way. Okay, and then once you've brought all that data into the STAAD Foundation Advanced solution, you will be able to design your foundation, get your report here so you can see the detailed report with all the calculations there. And you will also get your drawings created for those foundations. And then finally, you can get your BIM model there for your foundation. So complete 3D model with the design of the pedestals, all your reinforcement, the sizing of the foundations, all that information can be automatically generated from the foundation program. So we've covered this topic in detail. And if you go to our YouTube channel at Bentley Structural, you can actually see the recording of that workflow that we've just discussed. So today's topic is going to actually be in addition to that workflow. And what we're going to get into now is how do we optimize the foundation. So it's not just a simple design that is safe, but also we can consider other options and come up with the best solution. So that's our goal for today. All right, so now I'm going to actually share my screen here. I'm actually already sharing my screen here, but we're going to jump into a model. So you can see my desktop right here. So the first thing I want to do is let's talk about the new features that we've optimized in STAAD Pro and in STAAD Foundation Advanced and how that works, okay? We actually have a link to the release notes for STAAD Foundation Advanced. So we're going to be looking at the new release of STAAD Foundation Advanced version 9.2. And we have those notes on our Bentley community page, which you can see here. So the enhancement is that the algorithm for sizing of combined footings has been improved so that STAAD Foundation Advanced will produce better economically sized footings by placing a higher priority on increasing the lateral dimensions before increasing the thickness. So the added benefit of the soil weight is obtained for the stability checks for service load cases. So essentially what they're saying is when we're asking STAAD Foundation Advanced to design our foundations and size them, then what's going to happen is the algorithm prioritizes sizing of the foundation in its length and width rather than its thickness, so that we can get the benefit of the additional soil that's going to be on top of the foundation to offset some of those stability and checks. So for sliding and overturning, we'll get improvements there. And we're going to really see how this makes a difference especially when we're taking into account our passive pressure. Okay, so let's continue there. So the first thing we've added here is the new algorithm for sizing the foundation. Now, in addition to that enhancement that's going to automatically work on its own, all you have to do is choose to design a combined foundation. We've also updated our material takeoffs in the foundation program. So let's go ahead and open up the foundation program and take a look at that. And we're going to run a design for our foundation. So I have a few different models we're going to look at, and these models again, we started in STAAD Pro. So let me show you that as I go to my STAAD Pro. Actually, I think I already have STAAD Pro open here. And I'll open up the actual above ground structural model. It's the same one we saw earlier in the PowerPoint, but now let's look at it live here in STAAD Pro. And the reason why we want to look at this is because understanding our loading on the above ground structure is going to help us to understand the design for the foundation. So let's go and open this here, right? Okay, so here is our above ground structure. Here we can see the 3D model. Same structure we had before in the PowerPoint. Okay, now if we take a look at some of our loading, this is going to help us understand maybe how we should size our foundation. So again, this is an electrical structure, electrical substation structure. And so we're going to have the dead load, we're going to have an ice load, we're going to have a wind load. We have some extreme wind conditions and some other things, and then we have some combinations. So essentially we have 7 primary load cases, and then we have load cases 8 through 11, which are going to be combinations, okay? So if we take a look at some of our loading conditions here, for our dead load, we can see, we have some concentrated loads in the self-weight on the structure. Ice loads are similar there. And then we have wind. And so we have wind in the X direction, and that's going to be significant. And then we're going to have wind in our Z direction as well. Now, the importance of that is that these wind loads are going to impact the foundation in terms of sliding and overturning. So those lateral loads are going to place moments on the foundation as well as lateral forces that are going to create sliding and overturning. And we're going to have to design for that. So by understanding where those loads are acting and how they're acting, we can appropriately use that information to help size our foundation. So that's why we want to take a look at this. Now, again, after we've run our analysis, we can go right to our foundation program and bring all that information into STAAD Foundation Advanced. Okay, so we've already done that step. And so now we can just open up our foundation program. So the first foundation we're going to look at, and I'm just going to go right here to open. And let's go to the model here that we want to look at. Okay. And so we're going to go here to our foundation. So the first model we're going to take a look at will be right here. And this model is a model where we have already designed 2 types of foundations in here. So we've designed spread footings, and for the same structure, we've designed combined footings, okay? So if we take a look at this, all right, we have all of our parameters that are already set up. Again, we've covered this previously in other presentations, so we don't want to go through all of that again, but you're going to add all your design parameters for the foundation design, and then you're going to run your analysis in design, okay? Now, when you do that, it's going to produce a report for both types of foundations. So in this first analysis and design that we're doing, we're actually designing a spread footing here for each one of our column lines. So we're looking to see what design we get based on our parameters that we've set up. Okay, so let's discuss some of those parameters. So you can see here the detailed report that is produced. And what's new in this detailed report is going to be our material takeoffs. And this is what we're going to do now in terms of using this information to optimize the design. So if I scroll down here, you can see the detailed report that is produced. And what we've added to it here is our material takeoff. So now this data here is going to give us additional information on our foundation immediately. So we know how much the weight of the reinforcement is going to be here for this particular design. So we can see our reinforcement. We can also see the weight of the pedestal reinforcement. So this is just the footing, the pedestal, and then we get the total reinforcement weight there. We can also see our volume of concrete. So you see the volume of the footing concrete, volume of the pedestal concrete, and we get the total concrete volume. Additionally, now we get the formwork and we get the soil excavation and backfill volumes. So this is important not only for just the material cost of designing the foundation, how much steel and how much concrete, but also in terms of our construction costs, how much formwork do we need, how much excavation volume is there going to be, and how much backfill. So now this is automatically a part of your report that is produced. And we can use this now to compare different scenarios. So what do I mean by that? So this first design is for 2 spread footings. So if we look at our general arrangement view here, and I'm gonna choose to show the general arrangement for the current job only, and I'll hit refresh. So in this scenario, we've designed a square foundation for using spread footings at each column line. So that's the scenario we chose. And then the program automatically ran through the design to optimize for the thickness and the length and the width, and came up with this size. So 10 by 10 by 1.5 foot foundation at each one of our column lines, okay? So that's one design option. Another design option or another scenario would be that we have a combined footing instead of 2 spread footings for the same structure. So let's go now to the combined foundation option, and we can run our analysis and design for that. So what you'll see here is you're still going to have to enter in all of your parameters the same way you did for your spread footings, and then you're just going to run your analysis and design. And again, this is going to give you the material takeoff information. So you'll have the material takeoff information for your spread footings, but you'll also have the material takeoff information for your combined footings. So now this gives you the ability to compare very quickly and come up with the optimal solution. And so that's why that's a benefit here. So you can see how the combined foundation is being designed here. So this total foundation now is going to be 12 feet by 16 feet there, and you can see the layout and that all of that information. Now, if we scroll down, we'll also be able to see the material takeoff here. And I'm gonna go back up in just a minute, and we'll see also some important information about sliding and overturning and how we take advantage of that. So here again, we're going to have that material takeoff for our combined foundation too. So this gives us real values, real numbers for the weight of our reinforcement steel in our footing, in our pedestals, and then the overall volume of concrete, the formwork, the soil excavation. So we really have all the information we need now to make a good assessment. So we have one scenario where we have our square spread footings, another scenario where we have our combined foundation. Now, how do we compare this data together? Okay, and so that's where we're going to use our Excel spreadsheet that comes into play. So here I've set up an Excel spreadsheet, and in this Excel spreadsheet, I have put in all the data that I needed for each particular scenario. So this first scenario is we have a square footing on the left and on the right side of our foundation. And so we can copy paste that material information directly from our report. And then the way we've set it up is I've just added, since I know I have 2 foundations in here, I'm just going to add up that total weight of reinforcement there to get the design for both foundations. So I can compare that to the combined foundation. So here we get those total values there. And then we do the same thing for our combined foundation here, where we're only going to have one foundation instead of two, and we have those weights there and volumes there. And then that gives us the ability to compare both, okay? So when we copy paste those values, so let me show you how easy it is to copy paste those values in here. I'll do it for the combined foundation since we just ran the analysis on that. So right from our STAAD Foundation Advanced, right from our calculation package, we can highlight this data in here. So I'm just going to highlight this data, and then I'm going to hit Control-C to copy, okay? I hit Control-C to copy, then I go to my Excel spreadsheet, and this is for the combined foundation, and then I'll just hit Control-V to paste. Okay, so what it does is it pastes right into those Excel spreadsheet, and it has all those values. And then what I've done here is I've just put in the total weight, the total, so I've summed those up here. And then on this other spreadsheet, I'm going to access that information. So I've just chosen for this cell to this value equals the information on the other spreadsheet. So now I can do a quick comparison here on these two different types of foundations. So it's very easy to see what's going on. So in this first scenario, we have two square footings, spread footings, and we have a combined foundation. So here's our spread footings, and here's our combined foundation. Now, one thing you'll notice right away is that for the spread footings, we don't have any top reinforcement on the foundation, but for the combined footing, we do have top reinforcement. That's because we're going to have bending in the foundation due to it being a combined foundation, so we need that top reinforcement there, rather than those vertical loads just acting down and then the soil supporting that loading there. So we're going to have more steel reinforcement in the combined foundation. So there's a trade-off there where we have our square footings versus our combined footings. So we have more steel. Now, what about concrete? Well, in concrete, we actually are using less concrete in the combined foundation. And then when it comes to formwork, we actually have less formwork because we're just forming around the perimeter and we have the same type of pedestals. Whereas here, we're going to have to form out around these two foundations. So a little bit more formwork for the spread footings. And then we're going to have less excavation and less backfill. So based on this first scenario here, it's looking like even though we're going to have more steel for our combined foundation, overall for construction cost, it's going to be a better solution going with the combined foundation. So we're going to have a little bit more steel, but less everything else. Okay, so that's our first scenario that we've run. Now, are there ways to optimize our spread footings a little bit more? And so that's where we're going to look at some other values, okay? So let's go back to our spread footing job here. So I'm going to go right here to spread footing. And so we have our calculation package for our spread footing. And here is where we can actually look at another new feature in here, and that is a table for our factors of safety against sliding and overturning. And so we've always done these calculations, but the good thing now is we highlight the controlling load cases here. So you can quickly see which load cases are controlling for the design for your against sliding and overturning, and you can see your factor of safety that you're using. So as a structural engineer, I have the ability to control this factor of safety. And I can see that for my overturning, I'm well over the factor of safety in the Z direction. However, in the X direction, I'm close to my factor of safety. So my factor of safety is 1.5, and the actual value that I'm getting in this particular load case is 2.0. So I have some room here in the Z direction because I'm well over my factor of safety, but I'm getting close in the X direction. So we can consider now how we might modify our foundation to take that information into account. For sliding, we're actually in good shape here. You can see we have a factor of safety of 5 in one direction and a factor of safety of 7 in the other direction. So we're well above our required factors of safety there. So now, what can we do in this scenario? Well, we actually can take advantage of the geometry of the foundation. And so what do I mean by that? So here in this footing geometry, we're choosing to design the foundation or calculate the dimensions for a square foundation. And what I can do, let's take a look at how we would do this in another model. I've already run the analysis in another model, so we're going to take a look at the other model here. And by modifying the geometry a little bit, we can, let me go to this model. So I'll go to recent here, sorry. So by modifying the geometry a little bit, then we'll be able to optimize our foundation and still be within the range of the factor of safety that we want. Okay, so what I'm doing now is I'm opening up a second model. Now the second model has the same loading information, has all the same parameters set up, but in this model, what we've done here is when you look at the footing geometry, we're calculating the dimensions differently. So before we had our minimum dimension for the length of the foundation, that'll be in the X direction, as 4, and we had the minimum dimension for the width as 4, which produced a square foundation for us. But in this scenario, what we're going to do is we're going to actually make the minimum width 12. So meaning that I'm going to have a longer foundation in this direction. And so it's not going to be a square any longer. It's going to be a rectangular foundation. So by setting those dimensions differently, it will now optimize in a different way. So let's look at the results of that. So let's go here and run our analysis. So I'll go to Analysis and Design. And you can see how quickly this design takes place. And it's optimizing for all the load cases that we've considered and coming up with the design. So now, before we had a square foundation, if you look at our foundation now, at each column line, it's rectangular. So we started with a minimum dimension for the width as 4 feet and a minimum dimension for this direction as 12. And so this is what the foundation optimized to be. So we can see now how that compares in terms of our material usage and everything else. So this is the design for the left column line. And if we go to the right column line, we're going to get the same design there. So let's go to our general arrangement drawing. And you can see here now for this scenario, we have, because we're not using a square foundation anymore, we're using a rectangular foundation, this would be the layout that we come up with, which looks like it's a little bit more efficient than what we had when we used a square foundation design. So the main difference here was modifying the minimum values for the length and the width to come up and produce a different design. Now let's see, if we go to our calculation sheet, how this factors in for our sliding and overturning, and are we still in a good range for those. Okay, so here, this is for the new design, and what we'll see is that we're still in a good range, and in fact, for one of the directions, we actually have a higher factor of safety now. Before, for the X direction, we had a factor of safety of, it was 2.0, now we have 2.37, but we took a reduction in the Z direction, but we're still okay there. So we're at 2.79. So by changing that geometry a little bit, we still have a very safe design, and we have made the design more efficient now by doing that. And so we can easily see how these changes that we're making play out, and then we can come up with a great solution. Now, again, we can take those material takeoffs and compare that to the combined foundation. So we already have all the information for our combined foundation. We can do the same thing here. Take this material takeoff. So I'll copy this value right from our foundation design. And if I go back to the spreadsheet now, we have the optimized rectangular spread footing. So we can actually just paste this data in here. So just for example, it's already set up. I just hit Control V to paste, and that information is in there. Now, of course, the information matches because I've already run the analysis, and so we can see what happens when I paste that data in. And now we can go to our scenario 2 option, which is, what if we compare our rectangular spread footings to the combined foundation? And now we'll see that for the combined foundation, we actually are using more steel reinforcement, more concrete. We still have slightly less formwork because, again, you're going to be forming out the perimeter of the foundations there. So it's a little bit less formwork. But in terms of the excavation and backfill, now these values are very close to one another. And in reality, because these foundations are so close to one another, the actual backfill and excavation values will be very similar here. So we're not going to have a big difference in the excavation and the backfill volumes. So what does this mean? This means now that our rectangular spread footings are really going to be our best option here. We're getting a significant decrease in the concrete volume, a significant decrease in the reinforcement steel that we need. And so this is going to be our more optimal solution. Now, this might not be a big deal if we're just talking about one structure at one site. But if this structure, maybe if we're going to have 10 structures like this at a site, or if we're going to have 100 structures like this at multiple sites, then this adds up to a major difference in what we can achieve for a cost saving and a construction saving. So not only materials, but construction, labor, and all of that. So we definitely can use this in a very quick and efficient way to size our foundations and come up with the best scenario. Okay, so one other thing we want to consider here is that we used our material takeoff. We also took advantage of the algorithm that was updated for the combined foundation. But now we also want look at our passive pressure. So this is one thing that we haven't talked about, but it was improved in the foundation program as well. Okay, so let's talk a little bit about passive pressure here. If you look at the PowerPoint now, we actually have a book that discusses foundation design in a very comprehensive way. And this book was published by the Bentley Institute. And we have two of our senior developers for STAAD, Apurba Tribedi, and also another one of our developers. I don't know how to pronounce his name, but you can see it's written there. And they took time to develop this book to help people understand how to use the STAAD Foundation Advanced program in a very fast and efficient way, and understand exactly what each selection that is made in the program, how it impacts your overall design. So this is a good way to learn that information. So in chapter 5 here of the book, there's some information related to passive pressure. Now, when we're talking about passive pressure, we're talking about when we have a lateral force on our structure here, like we did on the substation structure. That lateral force is pushing the foundation into the soil. So since it's pushing the foundation into the soil, there's a resistance from the soil itself. So that's our passive earth pressure. And what we're saying is that we can actually use that passive earth pressure to optimize our foundation if we consider that pressure in our design calculation. Now, previously, we didn't have the ability to consider that passive earth pressure in our design calculation. So we only relied on the cohesion and our resistance from the soil friction. And now with the passive pressure, we can actually get a better solution that's more accurate for our different scenarios. Now, there's a couple things that you have to be careful of, and that's going to be a situation where maybe you have excavated a portion of the soil in the direction of the loading. So in that case, your passive pressure is not going to be a valid usage of additional support for your foundation. So you want to make sure that the conditions surrounding your foundation actually match the design parameters that you're using. So this is one situation where you would not want to take into account the passive pressure because you've already excavated that soil, and therefore the resistance from that soil is not going to be present. Okay, so here you would just want to use your frictional force there or your cohesion of your soil as your resistive forces, as well as the dead load and all of that. Okay, so those are some things to consider when talking about passive pressure. Now, let's jump back here into STAAD Foundation Advanced, and we'll look at one other model, and this is going to be based on the same above ground structure. So we're going to be opening up our last model, and we're going to take a look at how you can activate the passive pressure for your isolated spread footings. And one other option that we have, so let me go to my recent foundations here. And this is the one we want to look at. Now, in this particular model, I've made a couple of different changes, and we'll see how those changes play out, okay? So when we're talking about the passive pressure, what we've done here is for our isolated spread footings, when you go to your sliding and overturning parameters here, okay, this is where you have the option to consider passive earth pressure in your calculation. What you can also do is set your factors of safety against sliding and overturning. So you choose, as an engineer, it's your judgment on if you needed some additional factor of safety. Now you can increase that. So 1.75, let's say. You want to have a higher factor of safety because maybe you're going to be including this passive pressure and you want a little bit more, take into a little bit account more safety there and not be, and be a little bit more conservative. I'll just say, just be a little bit more conservative because you are going to consider the passive pressure. So you increase your factor of safeties. So you could, if you're worried about the sliding more than the overturning, maybe you're going to make your sliding factor a little bit higher and you can leave your overturning. So right there, you can adjust as you need to, okay? So that gives you the flexibility that you need to use your judgment as a structural engineer to consider these different scenarios to come up with the best solution. Okay, so we can do that. Now, the other option you can do is for your footing geometry, you can actually put in an offset in the X direction. So what does this mean? This means the column line does not have to be centered on the foundation. You can offset it a distance, and that's what we've done in this scenario here. So for the left spread footing, I offset the column line to the right 12 inches, okay? And now when we do our design, we're going to see what the impact of that is, okay? And, oh, there's one other thing I did too, which is I started with a different value. So one other thing for the footing geometry, not only did I offset the columns, but instead of the minimum width being 12 feet, I used a minimum width of 11 feet. And so now, that changes the overall dimensions. So here, if we look at our foundation design, this is for the left column. I have shifted, instead of that pedestal being centered on the foundation, it's shifted to the left there. Now, why did I do that? Well, I know I'm going to have another foundation on the other side, so there's going to be that lateral support in there anyway, and so I know that those foundations will be working together. So this is something that I can take advantage of. Now, if we continue down into our calculation package and we look at the resistance for sliding and overturning, what you'll notice is for overturning here, we're sacrificing a little bit in the X direction, but we're gaining in the Z direction. So we're still have a safe, we're still safe. We're still within the increased factor of safety there. And for sliding, we're fine. We're not worried about the factors of safety that we're getting for sliding. And again, this is taking into account that passive pressure as well. So for the overturning, you can use all that information and use your best judgment there so you can see that, okay? So that is basically how we would handle that. And in this particular model, what I needed to do is I needed to have a different offset for the left foundation versus the right foundation. So what I needed to do was set up a second job. So for the first job, I'm designing for the left column line, and for the second, I'm designing for the right column line. And so I'm going to have different offsets for each one, okay? So if I go to footing geometry here, this is going to have a negative offset in the X direction. And then you can see how this foundation is being designed here to be shifted the other way. Okay, and so it's as simple as that. When I run my analysis and design, it's going to do the analysis and size those foundations. So what we've added in to STAAD Foundation Advanced are features that help give you more control over the foundation, more control over safety, and better ability to optimize based on the real world scenario that you're working with for your foundations. And so that's what we wanted to talk about today. So you can see all of this information is being calculated in your foundation report here. So that's the great thing, that it is being calculated in your foundation report. And we're handling all that number crunching for you. You can take the material takeoff data here and use that information to come up with the best scenario for your foundation design. And then you also have your BIM model that's produced, as well as your drawings that are produced. So you're really getting everything you need in a very fast and efficient way, starting with your above ground structure, taking that information to your foundation. So you have the accuracy of all the loading coming over from STAAD Pro, coming into your foundation design as a starting point, having all the geometry laid out correctly, and then doing all the checks that are required by the code, and having control over your design. So this is how we've tried to give the engineer, the structural engineer, the flexibility they need, but also the accuracy and the transparency to understand the calculations, understand what's being done, and take advantage of that. Okay, so at this point, we're gonna take questions and answers, or we're gonna have a Q&A session. I'll take the questions and I'll give you an answer. So if we have any questions that we've been typing into the chat window, we want to actually review those questions. So we have about 5 minutes left to answer any questions. And let me see if I can pull up the, oh, here it is. So I'm reviewing some of these questions now. Give me a second to do this as best I can. I'm still learning how to do this, and looks like we have 2 unanswered questions here. Let me see if I can make the screen a little bit better. So we have a question from Amir from USA Structural. How does STAAD Foundation Advanced distinguish between clay and sand soils for sliding, overturning, and bearing? That's a great question. How does STAAD Foundation Advanced assign to freezing depth, and how does STAAD Foundation Advanced assign to the groundwater table? Okay, some of this information we've already covered in other presentations, and they've been recorded. So that's why I didn't go into all this in depth. But if you look at our design parameters here, what you'll notice is that we have the ability to assign parameters in our foundation design. And so we have the cover and soil parameters. Now this is where you're going to put in your geotechnical information for your soil. So you'll notice here I'm using a cohesionless soil. If I'm working with clay, then I'm going to have a cohesive soil. So based on the type of soil that you're using, you can choose those values appropriately. So here, that's where you're going to put in the unit weight of the soil. You're going to put in the depth of soil above the footing. You're going to also put in the depth of the water table. So I think that answers two of your questions there. But you can also put in the shear strength of the of the soil. You can put in a cohesion factor if you have a type of clay. So really, you're going to need some geotechnical information based on the site that your foundation is going to be at. And you can put in all this information. And these are the values that are going to be used for the foundation design. So I think I answered that question for you, Amir. If you have an additional question, definitely you can ask it again. Now, Jeremy from Jacobs asks, can the Excel file be provided to participants? Yes, I created that file. It's a standard Excel file. So I'll figure out a way that we can include that for participants, okay? And then we have another question here from Shenandoah with MGA Engineering. How do you get the foundation book? Okay, so that book is on Bentley Institute Press, so it is available. I want to give everyone my email address. So I'm going to type my email address into the chat window here. And you can email me directly, and I can, let me see if I can send to all. I have to select a question here. So the question is, how do we get the book? And then I'm going to send the answer. Sorry, let me try this again. I'm going to type my email address. Okay, so I'm typing it in now. Okay, so that's my email address. And I'm going to send to all. Okay, now, with that, you can send me an email if you need to get that book. I can give you specific directions on how to get that. I don't have all that information available with me right now, but it is available on Bentley Institute Press. So if you wanted to do a search on Google, you could probably pull that information up. And just for everybody, we're talking about the book that I was sharing earlier. So you can see that on my live screen now. Okay. Any other questions here? Can STAAD foundation ignore a certain depth of passive pressure? Say, for an example, geotechnical report states to ignore the top 2 feet of passive pressure. Now, that may be a possibility. So that question was from Jeremy at Jacobs. There's a possibility that you can, if you set the depth of soil above your foundation to the height of the soil that you want to neglect. So whatever depth that you're neglecting, you don't use that in the depth of your soil. So for example, here, when I put in the information of depth of soil above the footing, I would actually exclude from that value the depth that I wanted to ignore. So that is a way that you could handle that. So it's not exactly an option to exclude, but it's just a way to address that specific need, okay? So that would be my recommendation there. And I think we answered all the questions here so far. So I want to thank everyone for joining us. And let me just go back to the PowerPoint here for a second. And we'll wrap it up from there. So let me go. Oh, one other thing here, that we did have a poll question that we wanted to ask you before we wrap it up. for this presentation today, would you like to be contacted by our sales representative from Bentley Systems? And then I think I just hit submit there. So that poll should, you should be able to access that poll and either say yes or no if you would like to be contacted by a sales representative from Bentley System for either STAAD Pro or for this STAAD Foundation Advanced or any other of our Bentley structural products. So you can just answer that poll right now, okay? So hopefully I did that right. I hit submit and that should be done. Now, the other slide here, I'm still getting familiar with using this version of the presenter here, so bear with me. Okay, so I'm just going to go through this PowerPoint here very quickly, and then we'll wrap it up for today. We do have upcoming STAAD training that's available, so you can access that through our Bentley Learn server and register for those courses. Those are live instructor led. In addition to our SIG sessions, which we offer monthly. Also, we've had enhancements for our advanced concrete design solution in STAAD Pro, so you can get more information on that and see that in action. And with that, we are going to wrap it up for today. I want to thank everyone for your attendance here and your participation. And we hope to see you back in March. So thanks for attending, and look forward to seeing you back in March. Thanks again.